Hey, what's going on, Matt? Glad to have you with us today on this momentous evening. Happy Free Energy Fridays, everybody!
the depths of shadowed halls, I wandered all alone, casting whispers, binding chains, demons of my own. I seek deafening, down spread on my frail soul. I once feared my mirror, haunted by my role. But in the echoes of my cries, just still I emerge, guiding me to where my true results are. Now I rise from the shadows, with wings of fire I ascend, free from the chains of sorrow, while this path of forever depend. Shattered glass beneath my feet, stars I wear but dry. Stormy nights just turn to dawn, where truth that's my guide. Anxiety's dissolved in the sun's golden rays. See my destiny through time and space. The fears that once consumed me now they take. For in my heart a new world is proclaimed. Now I rise from the shadows, with wings of fire I ascend, free from the chains of sorrow, on this path I'll forever depend. With symmetry I found the power, let's expanded by the hour. Together we
In base lab alone with my mind, stable theories they all refuse to find. I've been working on energy for a brand new day, but even in the crowd I'm still a castaway. Alienated from the A's of added mentor in disguise. Ideas ahead of time dismissed with narrow eyes. Benefactor boy, dreaming about the world you can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? Talking left zero point, the points lost on them. Kevin structures crumbling from the same old stem. They laugh like I'm crazy, but I see it all so clear. Exploited labor, unheard injustice, burning ears. Fighting for a change in this wasteland of noise. But they call me foolish, wanting and boys. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice?
Alright, welcome, and welcome back to Beneficence TV Live. I'm your host, the Benefactor. And tonight's episode is a pretty significant one because we're taking everything that we've been working on with the synthetic AC model, and we're going to be applying it to the newest circuit that I've built, the solid-state impulse driver that you see running behind me. Now, this driver, the schematics for it, I haven't released to the public yet. However, I will eventually release those at a pretty close date to where we are now. I'll be releasing it on Patreon. So for our paid Patreon subscribers, as a great thank you for all your support in helping us open source zero-point energy technology here on this channel, as a great thank you, I'm going to be releasing that to our paid Patreon subscribers. You can go to patreon.com/beneficencetv. And, you know, all the links are available in the descriptions of all my videos if you want to help fund that research and get your hands on that circuit that I've been developing that we're going to be analyzing the waveform tonight. So, don't be afraid, though, because if you're completely new to the channel, I'm going to start from the beginning and explain what I mean by synthetic AC. Okay, Be explaining what exactly synthetic AC is, what the model is, and why I've been investigating these unusual pulsed systems using specific coil geometry, specifically the vortex geometry. And we're going to be discussing how I arrived at the experiments we're doing tonight. But then, we're going to get into something we've actually never done with this particular circuit before. Actually, not yet. Something I've wanted to do and haven't had the time. We're going to put it on the oscilloscope. I have a really high-speed oscilloscope, and I haven't had time to properly characterize the impulse driver's waveform yet. So when we connect the scope tonight, for the first time ever, we're not looking at a waveform I've already analyzed and prepared for you. This is raw discovery. We're going to be finding out the details together, forming a hypothesis, seeing where it fits into the model, if it does at all. And that's really important, because tonight isn't about pretending that we already know all the answers. We've discussed various theories on how the coil works, but I'm not pretending to have all the answers here. The question tonight is whether the impulse driver produces another form of resonant pulse behavior similar to what we previously observed in the lightning thief, and if so, how it fits into the synthetic AC model. So if it does, that could tell us something important about whether the behavior that we've been studying is specific to one particular circuit, or whether we're seeing a broader phenomenon associated with pulsed electromagnetic systems in general. And after all of that, after our mini lab, we're going to move into thermal measurements. This will only take a few minutes, or it should theoretically only take a few minutes to show you guys, but it's important to show this live on camera, the difference between standard battery recovery pulsed systems and the Bedini SSG, because they are not the same thing, and for some reason we haven't standardized the practice of conditioning batteries with the SSG. It's largely been dismissed as pseudoscience. Even the Mythbusters did a hack job on the Bedini SSG, so no one really knows what it's capable of. But tonight we're going to actually document the provable aspects of the differences between these two systems. Now, what I mean by that is the thermal runaway. Now, the standard pulse recovery systems are like smashing the battery with a hammer, right? So you have a lot of high amperage going into the battery. But with the Bedini SSG, you use very, very low amperage, and you kind of hit it with a hammer using the potential, the voltage. So it's a different method. And as a result, say you're using a standard pulse recovery system to desulfate a battery. Well, you're going to get around 90 degrees or more coming off of that battery. But the Bedini SSG only displays ambient temperature. It doesn't get above ambient. It doesn't get hot. Now, this is evidence that the system is far more efficient with less thermal runaway. And we're going to get into the specifics of that in a few, but just so we have it documented as evidence, and for your enjoyment on this live stream, we are going to show you the difference. I'm going to hook up a partially sulfated battery to a standard pulse recovery system. I'm going to monitor the thermal runaway, and you're going to see that it exceeds 90 degrees, while the ambient temperature of the battery will be measuring around 77 degrees. And then we'll hook it up to the Bedini SSG, and I'll show you the thermal readings and how they don't really go above ambient. So that is extremely important, because this kind of system is going to be vital when we have our inevitable energy crisis that is looming on the edge. We're on the precipice of an energy crisis, and I don't know exactly how long we have. I'm hoping at least 2 years before we start to have spots in the grid where we're having blackouts here and brownouts here, kind of like we see in Indiana. They had a grid blackout for over a week, and they had lines for gas down the street. It was insane. I'm not sure if it's still going on or not, but we want to try to develop some off-the-grid systems, some easy-to-build off-the-grid systems for people, so they have some real tangible solutions, so they don't have to scramble to get gas every time the power goes out like that. This system is extremely efficient. You can get a $20 or $30 20 amp hour 12 volt battery, and it'll run your lighting for over a week. And I think that is extremely important because no other system will be able to get that kind of use value out of your battery. Your battery is not going to last more than a day with the most efficient systems on the market. And even then, you're going to be paying up the ass for that kind of system. Now, this system is relatively cheap in comparison. It's easy to build for any kind of garage engineer, and we have everything open sourced and displayed in a do-it-yourself guide, a comprehensive guide linked to in the description of all my videos for your convenience, because this technology and the science behind it should not be kept behind a paywall. Now, I have to keep a couple of things that I've invented behind a paywall just to keep the research going, to keep the lights on, as it were. But the science is all open source, and it should remain that way. The synthetic AC model, if it pans out to be vital for engineering in the future, is going to remain open source. It cannot be proprietary. It is scientific knowledge, and it belongs to everybody. Now, what you do with that knowledge, those actions should be regulated. But the knowledge itself should be out there. And the fact that we actually don't have systems taken seriously that are actually working on the bench now, as you can see with the Bedini SSG and other systems, it's kind of unfortunate that mainstream science still doesn't take these kinds of ideas seriously. So we're going to have to push past the mainstream and into the fringe and try to convince people by replication and hard data, hard replicatable observable data and facts. So that's why I try to boil everything down to a layman summary of what's going on, not just for my own convenience, but for your convenience as well. So somebody has an idea of how this is possible. They don't violate the laws of thermodynamics, because when somebody says that, we've discovered recently that phrase is a gross misunderstanding of the laws of thermodynamics, right? We have two different kinds of systems that we can apply those laws of thermodynamics to. We have closed systems, and then we have open systems. And the difference is that boundary condition we were talking about last week, and where you draw that boundary. And depending on where you draw that boundary, you can have additional inputs, say from an environmental gradient, that you don't have to physically tap into yourself. For instance, a river or a windmill, they use an environmental gradient to sustain that input. So that is, what we're trying to do is dismiss all these misconceptions, because free energy in itself, the idea behind it is real, but the phrase free energy is I wouldn't say gross mischaracterization, but it is a mischaracterization of what's going on. It's largely used as a pejorative, right? Somebody says free energy, it assumes you're pulling energy out of your ass, and that's not the case. There's no free lunch here. It's mutual exchange from the vacuum. What you're doing is you're tapping into environmental gradients and environmental energy that would otherwise not be accounted for or even seen in other systems due to the way that they interact with, electricity and magnetism. So we're thinking about these things in a different way. And oftentimes a radically different way, because we're utilizing the recovery event of the coil, the collapse event, the back EMF, which is largely underutilized or dumped and grounded out in most standard systems. Why would you do that when you have a method to actually utilize that energy and increase your efficiency and your COP, therefore? So it's complicated, but then we're trying to boil it down into a way that most people can get their head around and try to get around some of the propaganda surrounding these types of devices, because, they've largely been discredited in the mainstream, where in this channel we've looked at a few devices and got them running. We look at the Mythbusters and their episode on the Bedini SSG. It's a complete hack job. Anybody who's done even 5 minutes of research into the Bedini solid schoolgirl circuit knows that the Mythbusters missed not one, not two, but many vital components. They didn't even have a flywheel, a magnetic rotary of any kind. They basically hooked a battery up to another battery and said it was debunked. And that is, in my opinion, not just irresponsible, but it should, in fact, make you rethink how seriously you take the mainstream science opinion of the subject that we're talking about. And it goes back to people proclaiming to know the answers of a subject they know little about, right? How can you know that the Bedini SSG doesn't work and it's a fake system if you haven't built it to the spec that John Bedini himself said that you need to, right? He said, and I quote, "Build it like I tell you. Don't stray from one component. Build it exactly to the specifications that I have laid out." Because what we often see is in these systems, somebody who is maybe disingenuous, somebody with a ulterior motive, maybe somebody going into a replication of one of these systems with a bad intention, with an intention of debunking it. They will go into it and they will build it purposefully wrong. They'll miss a component here or there intentionally and then step back and say, hey, see, doesn't work. So you have to pay very careful attention to what the inventors say in how to replicate these devices. Going back to the thunderstorm generator as well, Malcolm Bendel has laid out extensive guides and videos on how his system works and how to build it to the specifications that he requires or it requires to function. So, he has stories of, people calling him up and saying, hey, we built your system and it doesn't work. What's going on? And he's like, okay, send me a picture, send me a video, let me take a look at it. And he's like, oh, well, you have it grounded out on this, platform. It's not supposed to be on this kind of material, right? So, you have all these little tiny mistakes that you can make if you're not paying attention. And, that's unfortunately what a lot of replications have led to in this realm. A lot of the inventors, unfortunately, keep the secret sauce to themselves in general, which makes replication extremely hard, if not impossible. Floyd Sweet was notorious for keeping the secret sauce behind his vacuum triode amplifier to himself. He didn't tell a single person, not even Lieutenant Colonel Tom Bearden, who he was very close with at one point, and helped document some of his work. So we have a lot to get into tonight, but it's going to be an exciting night because we're going to get back into the lab, get our hands dirty, and get some oscilloscope readings for the first time ever on this new impulse driver system. I'm very excited about that. What's going on, Elias? How you doing? Hey, Math Easy Solutions. Just a reminder, we're going to be on Matt's podcast tomorrow, Math Easy Solutions, tomorrow at 4 p.m. Eastern Standard Time to go over some of these latest bullet points in my research, probably going over the results that we find tonight as well. But I wanted to discuss on his podcast some of the circuits that I've been developing and some of the future experiments that we're going to be going into. And also, I did want to emphasize to his audience, that key difference between open and closed systems, because you can't just say, that violates the laws of thermodynamics without extensively knowing where your boundary is drawn in your system. What is your system, right? So if you have a pot of heating water on a fire and you're drawing the boundary at the pot and you're just analyzing what's in the pot, you're not going to see the fire, right? And even if you draw that boundary around the fire, imagine it being in a fucking volcano. If you don't draw that boundary further, you're not going to see that extra energy in the environment, if that makes any sense. So it's very important to understand the fundamentals before we just go ahead and dismiss something straight out. Now, we're going to do a quick recap of the synthetic AC model. So for anyone new to the research I've been doing here on the channel, let's establish what I mean by synthetic AC. So the basic idea came from looking at what was actually happening in the pulsed circuit I like to call the lightning thief. It's a modified joule thief variant using a vortex coil as its driver. So rather than assuming that a conventional alternating current waveform has to come from conventional AC source only, I was looking at the system. I'm like, okay, so this is pulse DC. So why am I getting such a strong AC signal using my amp clamp basically all around the system, including at the battery, which is very unusual. If you have a pulse system, traditionally with a standard coil, the AC won't be that strong. It's not going to be as strong as it is in this system. The system steps up the back EMF like 10, 20 times in some instances at some frequencies. So you're just not going to see that kind of output, first of all. But secondly, you're not going to see that kind of big AC output, or you're not going to register that big AC field around the battery. And that's what we've witnessed. So we have a huge AC output from this pulse DC system. And as a result, it's showing a unique waveform that I've classified as a resonant pulsed waveform, simply because one of the characteristics is that we see these three defining characteristics no matter where we probe the system, including at the battery. So this is all evidence that something strange is going on in the system that is unusual compared to conventional linear systems. So in a conventional AC system, we normally think of the voltage or current continuously alternating polarity according to some periodic waveform, right, or frequency. So you have a bit of energy going in a wire, and then it's reversing polarity and coming backwards, dissipating some of its potential while doing so, right? It's fighting its own momentum. It's creating heat and resistance. But imagine two pulses, one pulse going forward and then a correctly timed recovery pulse that creates an alternating effect between the two. Now, using the correct timing of the circuit and correct geometry of your coil, this is possible. We've done it in the lab, and this is what we call synthetic AC. It is not fighting its own momentum. It is not polarity reversal. It is not conventional AC. It is something else, so it had to be classified as something else. Now, traditionally, we just lump these into the same category throughout the history of electronics. AC has always been AC. No matter what kind of signal you're picking up on your amp clamp, if it's an AC, you call it AC. But in our research, we've kind of discovered that the origin of that wave matters immensely, because it can tell you how that wave is transferring energy. Now, waves don't transfer energy the same. There are different waves that transfer energy differently, specifically transients, like impulse events. Now, you think of a pulse. A pulse is, you have a bit of energy going into a coil and then stopping. So you turn on the battery and you turn it off. That's a pulse. It has a start and it has a stop. But when you pulse these coils fast enough, you create an impulse. Now, an impulse has the start and stop overlapping. They are the same event. They happen so fast, there is no lag time between them. And this is important because this tells us that we're using a different type of wave in our system, and that wave can potentially be transferring energy quite differently. And if we're averaging everything out using RMS standards and practices like we do normally to calculate the efficiency, we're just not going to see what's happening in these systems, because the frequency of these impulses is so fast, it's going to get smoothed out, and it does. It renders them invisible. So you have a lot of energy coming out of the system, and you're never going to be able to capture all of it with the standard RMS method. That is why we're moving toward a new mathematical framework for these kinds of systems I like to call instantaneous power integration over time. So basically, we're going to measure everything in absolute units of work, joules, and we're going to measure the instantaneous input as well as the two separate events that we see as two separate thermodynamic events, right? We're not, traditionally, you dump the back EMF, so you're not even going to measure it. But if you do end up measuring it, it's going to be lumped into the same RMS value. Now, what we're doing here is, since we have partitioned energy in our system and we can prove this, with a huge asymmetrical output of a negative 168 volts on the same output as we get positive 10 volts. So that's partitioned energy, and that means that we have to calculate the forward and the backward recovery as separate events, separate thermodynamic events, and we calculate their units of work in joules, and then we add those, and then we basically have our adjusted COP formula. Now, in my opinion, this should give us a more accurate way of measuring the efficiency of these types of systems. Now, is it an answer? We won't know until I get my current probe and we test it out. But it is a way forward at the very least, because as John Bedini and many other researchers before him have emphasized, including Tesla, you simply cannot read this kind of energy with standard meters. You're never going to pick it up. All right, so these circuits that we're working with are different. They're different than standard circuits. They're being driven by pulses of energy, not continuous flows of energy. You have an excitation event, and you have a magnetic response, a collapse event, and that's the recovery event. And that collapse of the magnetic field produces a returning transient wave. When shaped correctly with the correct geometry and magnetic field arrangement, as seen in the Bedini SSG, we get something called what Bedini called an H wave. It kind of looks like an H on the negative side of the oscilloscope. So we're literally shaping the energy. And the question I've been investigating is what happens when those forward and returning events become sufficiently synchronized that the system begins behaving like a coherent AC waveform. So that was the premise behind the model that we've been developing to help us understand what's going on with these systems and why this type of coil, the vortex coil, the Rodin coils, are so unique, why they produce such unique phenomenon. The hypothesis is that you can create an effective alternating behavior from the interaction of pulsed forward excitation and synchronized returning energy, the collapse event, the back EMF, kickback, rather than just beginning with a conventional sinusoidal AC source and just reversing the polarity of sloshing the same energy back and forth, wasting some of it as you do so. Now, the important word here is interaction. We're not simply taking DC and calling it AC. We're looking at the temporal relationship between the excitation pulse and the returning electromagnetic response, the recovery event. And that distinction becomes extremely important when we look at the oscilloscope tonight, because the waveform itself is where we can start asking what is actually happening. Is this repeating, right? Is this fitting the synthetic AC model where we see all those nested harmonics and then we zoom out on a larger scale and see that converge into a kind of a smooth sine wave, which is very unusual. You have chaos kind of slowly merging into shape and form and function in a way that I have not seen in any other waveform. That's why we had to classify it as a unique waveform. It's called the resonant pulsed waveform, and we're going to go into the the defining characteristics and all that in a few minutes before we go and start the interactive mini lab. But suffice to say, it is an extremely unique waveform that you will not see with any other type of system, potentially different types of vortex systems. So what I mean by that is we have instead of the lightning thief, we're going to be testing the impulse driver circuit. I don't really have a name for it at this point, but if the model holds up and if the theories are accurate, then we should see some of the same kind of characteristics that we see in the resonant pulse waveform, if not more so. If it's more efficient, we should see nested harmonics, but more nested harmonics. And what I mean by that is it's just one string of energy on the oscilloscope, right? It's just one line bouncing off of itself, though. So you see like secondary and tertiary lines. You don't see just one line, and there's squiggly kind of bumps. Now, you pause it on the oscilloscope because it's in motion, and it's showing us what's happening over time in real time. If you pause it, it's just one line. It rectifies just into one, line with a couple of bumps. So it's one line bouncing off of itself in a very chaotic manner. Now, if my theory holds up and this proves to be more efficient, we could be seeing more nested harmonics on that scale. Not just third lines, but maybe 4 or 5 lines bouncing off of itself. So more chaos, more nested harmonics is what we want to see if we're going to be looking for high efficiency in the system compared to the other system. Now, we want to see that rectify into a somewhat of a smooth sine wave, though, because as we've seen in swapping out the coil, like we're using the same circuit, swapping out the coil for, a pancake style coil instead to see what happens. That system is far less efficient, and we see that play out as kind of like a bell-shaped curve on that same scale compared to a smooth sine wave. So this is very interesting. It tells us that the energy isn't transferring as smoothly as the other coil does, right? You have the smooth transfer of energy as a smooth sine wave on the macro. All the chaos is conforming into order. But with the bell-shaped curve, it's not smooth. It's kind of like a dent in the middle. So to me, that indicates that the energy isn't transferring as efficiently. And we do see that system is far less efficient compared to this system, the Lightning Thief with the vortex coil, which is basically a 3D extension of the pancake coil in and of itself. So a pancake coil is just a spiral and using 2 dimensions. The vortex coil is that same spiral, but using vortex-based math, number sequencing, and a 3rd dimension, right? So it's and the simplest way I can describe it is an extension of Tesla's work with his pancake coil. It's a direct extension, in fact. And honestly, since we don't know what were in those 3 missing trunks when he passed away, a lot of the stuff he kept secret, he could have been looking towards that design way before, Marco Rodin came out with vortex-based math, because as Marco said himself, this is nothing new. You'll find they use this kind of math in the Sanskrit text. Sanskrit math is relatively the same as vortex-based math, it's modular 9. You reduce everything to a single digit. And in this way, we're replacing, variables for functions. We're swapping the roles. So if you're new to this, it's a lot to take in, but just stay tuned, because we got a couple of videos to go into before the mini lab that should help explain everything and put some kind of visuals to what I'm describing here regarding these new waveforms that we're seeing in this type of system. A very unique type of waveform. So, before we get into all that, I still want to explain how we got to this point. Because this didn't start with the impulse driver. This is just the latest circuit. So we've been building towards this through several different experiments. One of the most important experiments recently was with the stereo amplifier. We have a stereo amp receiver hooked up to the coil and a tone generator. And the whole system's hooked up to a 12-volt battery. The experiment produced an observation that was really remarkable. Now, we experienced battery reversal while under active load. Under no circumstance should this happen. If you see that, it's usually a fluke, a measurement error, and you see it real quick, or it's instantaneous, or it happens for a few seconds and goes away. It's surface level effect. This was a sustained, continued increase in battery reversal directly tied to the spinning of a magnetic, a virtual magnetic rotary, but it's a magnetic sphere that we have spinning in the coil. You take that sphere out or you desynchronize it and the battery stops climbing. And this is very important because that tells us it's directly tied to that spinning movement of the magnet. Now, it's not evidence of a self-sustaining system, or it's not proof of a self-sustaining system, but it is evidence. The first evidence that you're going to want to see if your system is getting some kind of free energy or energy from some kind of environmental gradient outside of your input, the first thing that you're going to want to see is your battery, your source, either staying as it is or going up. Under no circumstance should your bucket of water be filling with more water than you put in. Where's the extra water coming from? Okay, so this is very important. Again, it's not proof, but it is evidence enough that people should be fucking looking into this. And I'm goddamn serious. It's about fucking time that we have a system displayed online that is not hidden behind some kind of obscure secret sauce kept by the inventor. This is all open source. I explain every single step on how to reproduce this effect. And it is fucking important. And listen to me, people. This is important. We reversed a battery's voltage while it was powering a significant amount. It shouldn't happen under any circumstance. And at the very least, we need more people looking into this effect. Because what it says is that there are certain things that even mainstream science is missing about simple electronics, about simple circuitry, electricity. We think we know everything there is to know about electricity, but we're using the wrong aspect of it. We're underutilizing the negative aspect, the recovery event. We're wasting it. This isn't free energy, ladies and gentlemen. This is energy recycling. This is what we should have been doing 100 fucking years ago. Okay, when Tesla had a car that ran on basically thin air. He had a system hooked up to a car, and he had probably some kind of capacitor bank, and he had it running basically off of the atmospheric energy. Somehow he was tapping into the magnetosphere. So, again, this isn't proof, but it is significant evidence, and it's the first evidence that I've ever seen documented online of a self-sustaining system potential. Now, I emphasize self-sustaining because perpetual motion is largely a misnomer and a pejorative. When somebody says that system is a perpetual motion machine, that's an incorrect classification when we're dealing with these types of systems because it's not perpetual motion. The tolerances in reality for perpetual motion are astronomically high, too impractical for any kind of system that we're trying to develop here, that anybody can develop in their garage. So what we mean by self-sustaining is a system that is unaffected by the weight that it carries. It's not fighting itself. It's working with that recovery event. Now, you can imagine normal systems that use coils, they're fighting against that backward pulse. They don't know how to work with it. So they fight against it and they ground it out. They waste it. It's like a surfer fighting against the current. All that wasted energy. But no, we're riding that wave to shore, ladies and gentlemen, with these systems. And we've proven this time and time again with the runtime of the system being far exceeding anything theoretical 100% should be at regarding our control experiment with, our traditional transformer. So we started all of this with the Lightning Thief, a modified Joule Thief circuit that my former lab partner and mentor, Michel Morel, was able to whip up for us in some neat little printed circuit boards that I've been using. And those circuit boards will be on the market soon. I am going to aim at looking at distributing some for free as well to researchers who already have vortex coils. Ian, Bog Irish might be interested. Nathan from Old Man Builds might be interested. Obviously, I'll look into sending a few of them out for free so they can experiment with these boards as well. I've been meaning to do that for a while. And I do apologize, but we're finally getting to a point where I can actually understand some of this stuff. And I was really hesitant to send out these boards before I understood the system well enough. And that's simply because I don't know how to use the open circuit method. Michel Morel, I've asked him several times to explain or send me schematics for the open circuit method on the PCB, and he hasn't yet. So I don't know what he did with the open circuit method. There's a closed circuit method, and that's a standard joule thief that you'll use. But he also has an open circuit output, and I have no idea how he has that configured, and I've not been able to get it to work. And I was hesitant for a long time to send these out because when I experimented with the open circuit method, hooking it up wrong blew the board very easily, because you have all that back recovery energy going through the wrong path, and it literally blows the line on the board. You can see it, the metal's gone. So, and it pops, it sparks. So it's very, very easy to break that board if you don't know what you're doing with the open circuit method, and I still don't know how to use it. So that's been a large mystery to me, but I'm at the point where I'm like, okay, it's worth it. I'll send, these guys with maybe 2 or 3, just instead of 1, just in case they blow one up, they'll have a couple extra, because maybe they can figure it out. I'm relatively a layman. I consider myself a layman at most of this stuff. I'm a newbie. Nathan has been doing this stuff for years. Ian is a professional. He's made some amazing advancements with these different kinds of geometries for your coils, and specifically working with different kinds of Tesla coil setups. So these guys, I'm confident, will figure it out. So that's why I want to get these boards out to as many people as I can, at least people who want them. I've offered to a couple people already who didn't really seem interested, unfortunately. But if you are interested and you have a working vortex coil that you've been working with, please reach out to me. I will consider sending you a PCB to experiment with. beneficencetv@gmail.com. So please send me an email if you're interested. I want to get some of these PCBs out there because I'm like it's a pet peeve of mine. Like, I really want to solve this open circuit method, whether it's me or somebody else. I want to know the answer of how to use it, because I think that it could yield more efficiency than the closed circuit method. But that's just a hunch. We don't know that for certain, because honestly, I don't know how Michel has it hooked up. I've got different theories and different ideas about how he did it, but until he sends me the actual schematics, I have no idea. Maybe somebody can look at the back of the board if they know how to trace it. I've tried to, but I'm not an expert. So, I have to, outsource that job to somebody who actually knows what they're looking for and knows how to, maybe reverse engineer, then reconstruct that. But as far as the new system is proving to be more versatile than the Lightning Thief. And what I mean by that is you have way more options. You're now not relying on a self-feedback loop, right? You're actually able to control the frequency. So with the Lightning Thief, it kind of just settles into its natural resonant frequency for the coil, whereas this new system, we have a pulse width modulator, which you can input a specific frequency and a specific duty cycle. And, you have multiple resonances or harmonics of the resonant frequency that you can achieve and different points of efficiency. And we're going to monitor that with the oscilloscope tonight, because I have a feeling that at certain frequencies, we're going to see some really interesting things. Now, the Lightning Thief was particularly important, though, because it's where we began identifying the resonant pulse waveform. It's a very, very unique waveform. You'll never see anything else like it in any other kind of system except for this kind of system. I guarantee you it. At least I've not been able to find anything. And everybody that I've shown the waveform to is honestly flabbergasted in complete awe. Like, holy shit. Like, what the fuck is that? Well, we're going to attempt to describe it, and hopefully some of these theories are correct, but at the end of the day, they're just theories. So the interesting thing, though, was it wasn't a traditional waveform that we picked up, right? It was chaotic, very, very chaotic on the default scale. But when we zoomed out, all that chaos just converges into kind of a smooth sine wave in a very unusual way. So these characteristics led to a question. If this behavior is real and reproducible, can we find it somewhere else? So synthetic AC, the model, tells us we should be able to find a similar waveform in a different kind of pulsed system. Now, this system is very similar to the lightning thief, only it uses a PM pulse width modulator. So I don't know. My instinct is that we might see something similar at certain frequencies, but we might see something wildly different at other frequencies. So we're going to look at all that tonight. And again, this is the first time I've never analyzed this system I haven't done this yet. So I'm going into this blind just like you. So we have a couple of predictions. My prediction is that the impulse driver may produce another type of resonant pulse waveform. Maybe something not identical, but obviously in this prediction, I think we're going to see the fourth defining characteristic as we see in the resonant pulse waveform, which is no matter where we probe the system, we're going to see three other defining characteristics consistent with those probe locations, which shouldn't happen. I mean, you should see different kinds of waveforms depending on where you're probing your system, at least albeit slightly. But if you're seeing these three defining characteristics, that's going to be significant because that tells us we are seeing some kind of system-wide resonance instead of a traditional LC system where you have resonance between, a couple of components. No, this is system-wide resonance. No matter where you probe in the system, you're going to see that resonant effect being placed there. So it may not look exactly like the waveform we've observed with the lightning thief. In fact, I don't expect it necessarily to look identical at all. The circuit topology is different, right? The excitation method for our coil is different in the circuit. The coil configuration is slightly different. But we're looking at those common characteristics again. We're going to be looking for things like repeating waveform structure, nested harmonics, a single line bouncing off of itself in a very chaotic manner. We're going to be looking for, on a larger scale, some of that chaos, zooming out into kind of like seeing more structure. So like more of a smooth sine wave. We're going to be looking at the relationship between the forward excitation and the returning transients. Pulse relationships, changes under load. We're going to try a couple of different light sources, maybe put a fan on it or something and see if the waveform changes. And we're going to be looking at evidence. We're going to be looking for evidence that the system is operating in a coherent, repeatable manner. And after all of that, after we analyze the oscilloscope readings, we are going to actually attempt the Sheila-Raman method of utilizing the oscilloscope to view a coherent waveform. So what I mean by this is there's a specific method that she employed during the Cosmic Summit where she showed us the resonance, like visually, these waveforms, right? When you were able to set them up on the oscilloscope, so visually they loop back into themselves. Normally, in a normal system, you wouldn't really see an even circle, right? It would be asymmetrical because you'd have some kind of loss. But in these systems, you see, like amazing designs, specifically when you're inputting frequencies from the plasmoid unification model like she did. And we're going to watch that video as well. But we're going to be trying that method to see if we can pick up those waveforms and see what they look like as well, using the XY method, trying to visualize that energy flow. So that's going to be interesting. I know S&A Organite Creations, they also did this with their coils, and I don't know exactly how they did it, but I have an idea, and we're going to be trying it tonight. So if it works, cool. If it doesn't, back to the drawing board. So if we see characteristics that are comparable to the RPW, the resonant pulsed waveform we previously identified in the Lightning Thief, that would be very interesting and give more evidence to support the synthetic AC model in its entirety. That would tell us, synthetic alternating current behavior is able to happen in multiple systems, right? You have the same kind of interaction between the forward and the backward pulses in this system as you have in this system, and we can pick that up and see that the energy is not being wasted but being transferred efficiently compared to other systems. So that gives us that would give us a much stronger reason to investigate whether there is a common mechanism behind both systems, right? We want to understand not just what's going on, but why it's happening. And up until now, no one's really had a mechanism of action for these kinds of coils outside of the esoteric vortex-based math theory, which doesn't really tie into standard electrical engineering, and it doesn't really give us a mechanism of action regarding some of the unique effects. Like the coil is able to produce a lot of step up, step down effect with a 1-to-1 ratio of coil, which any other coil simply wouldn't do that. You need asymmetry between your coils in a transformer. Everybody knows that. But why is it doing that? Well, vortex-based math doesn't really have an answer for that can explain it in any real scientific sense that connects to, physics. But field cavitation gives us a mechanism of action, which we can say, okay, this makes sense. This is how this is stepping up energy with just a 1-to-1 ratio of coil. Now, field cavitation is one of the theories in the synthetic AC model. I'm not really going to be touching on it tonight. I've gone over it many, many times, and if you want to delve into it, all the links are in the description of my video. But suffice it to say, field cavitation does give us a real mechanism of action for some of the unique effects of the coil. It really demystifies it if that is actually what's happening. And so far, all of our experiments kind of support this idea that this is what's happening. This torsion field is creating a null zone in between two counter-rotating fields of energy. And this null zone is basically a micro dot of a vacuum, maybe only a couple of microns across, very, very small, just a pinpoint. But it's enough for nature to say, hey, fuck you, I don't like vacuums, I'm going to try to fill this with something. And that's what we see. Potentially it could be pulling in stray electrons and free ions from the environment, which, there's plenty in abundance in the environment already. So it's just like bubble cavitation in fluid, right? You have a vacuum in the cavitation area, and nature just rushes in all that water, all that pressure very, very fast to fill that void because it doesn't want that vacuum to exist. So in my opinion, this really demystifies the Rodin coil in a lot of ways and gives us a real understanding of how these coils are doing what they're doing, and push them out of the category of pseudoscience and into something that should be standard practice, honestly. So, without further ado, we're going to watch the synthetic AC comparison video where I go over the 3 and 4th defining characteristics of the synthetic AC waveform, the resonant pulse waveform. So we're going to watch this video, and we do compare it to the pancake coil in there so you can see the differences visually. And I might take a quick break after this, depending on how I feel. We might take a quick break, and during the break, I might play the Sheila Raman video, the Cosmic Summit video. Or maybe I'll play it before the break. But I want you guys to see those waveforms, because we're not going to be able to recreate what she did. Specifically, she has custom-made software, or a plugin for her software, her music software, that allows her to input multiple frequencies on top of one another. And she uses frequencies from the plasmoid unification model. Now, the plasmoid unification model has certain frequencies that are grouped together. And when you group these frequencies together, according to Malcolm's model, these are the frequencies that are required for creating matter and life. And when she inputs these frequencies, they create these really intricate, coherent patterns. Some of them display somewhat of what appears to be sacred geometry to some certain to a certain point. So I think that's important for you guys to see, because when I saw it, I was really impressed with that. And I always wanted to recreate that, but I don't think she has put her plugin on the internet. I don't think it's publicly available. If anybody knows if she has it anywhere, a link anywhere to download that, I would definitely recreate exactly what she did, because I have, I'm a musician myself. I have the ability to do that. I just need the plugin for the software. So that would be really cool. But we're going to watch the synthetic AC comparison video so you guys can get an idea of what I'm talking about when I'm saying resonant pulsed waveform and nested harmonics. Here we go. Oh. Alright, so we now have the oscilloscope hooked up to positive of the lumen lamp output to the load, to the light. Okay, and look at this waveform. It's completely different. This is a different beast entirely. Okay? You don't have that ringing. It's a little bit, but not in the same realm as what we're getting with the Lightning Thief. So look at this. This is very interesting. Okay, so what we're looking at here is zooming all the way in on the microscopic scale of the waveform with a high-speed oscilloscope and a floating probe. So with the Lightning Thief system, zooming all the way in on the very, very micro scale, we see what appears to be some kind of pinch point. I've been calling this the 0-point convergence because what it appears to be, and what my opinion is it's showing basically the transfer of energy. It's showing two fields, basically two tornadoes touching, right? It's showing two fields interacting with each other, at least based on my opinion. Yeah, I could be wrong on that. That's just what it looks like. But we don't see that kind of major sideband activity with any other, design for a coil that we've tested so far. So you see these big, thick sidebands of energy, kind of just like energy squirting, left and right. And that's kind of like minimalized. There's really no sideband activity with other coils. So that's the first characteristic that I was like, this is interesting. There's a lot of energy coming out of the left and the right of this little pinch point here, but not on the other system, or not on the other coils that we've hooked up to the system. So that's important.
It's a nice waveform, but it is not the same. It's not, I don't think it's a resonant waveform. I don't know. I have to do some analysis, and it's slightly trying to ring.
Okay, so here is the nested harmonics for the pancake coil on the same circuit. It looks like it's trying to ring. It looks like it's trying to bounce off of itself, but it's not. Like, it's not the same as in the RPW. It's almost like it almost looked like it's maybe the wrong frequency.
See? But not.
And it's unfortunate you can't really adjust the frequency of this, system. It kind of just settles, because it's a self-feedback system, so it kind of just settles into its natural frequency based on the wire length of your coil. I'm wondering maybe if we can adjust that resonance with that same, maybe using the pancake coil with my new circuit, now that I'm thinking about it, maybe we can get something to look similar to the RPW. Maybe. I mean, because if you think about it, if field cavitation is what's happening in these coils, there has to be other systems using other kinds of, methods that produce a similar field cavitation effect. So it's not out of the realm of possibility to believe that other types of coils can achieve field cavitation under the right circumstances. We probably should assume this to be true.
In the same realm that we were with the lightning thief. Here, I'll hook up the probe to the lightning thief right now and show you. It doesn't matter where I hook it up. Could hook it up right to the battery terminal. We get the same waveform. And look at this. This is like more of a perfect sine wave when we zoom out. But when we zoom in, let's go down a little bit because we had to adjust for the other device. So look at this. It's almost like it's it's almost like it's synergy, and it's like harmonizing or reflecting off of itself in a very peculiar way that seems to be very, very stable when you zoom out and look at the nice sine wave appears at the macro scale. And in the micro scale, you get kind of like these, I don't know if they're H waves or what, but, and they're bouncing off each other, and there seems to be like this focal point right here. This is very, very peculiar.
I concur. It is very, very peculiar. And I'm hoping to see something similar tonight. Again, for the first time tonight, we are going to be analyzing the impulse driver, the new circuit I've been working with and developing with the oscilloscope. I haven't done the oscilloscope readings for this circuit yet, so it should be really interesting to analyze those readings tonight. Before we do so, I think I'm going to go take a quick break, and while we're in a break, I'll play the Cosmic Summit video where it goes over some of the highlights from Sheila Raman's presentation. Now, this isn't the most recent Cosmic Summit. I believe this is the one the year before last year. I'm sorry, last year's Cosmic Summit, not this year's. Wait, no, was it last year? No, it might have been the year before last year. I'll have to double check. It was the first Cosmic Summit they did. It was in 2005 or 2004? Or 2025 or 2024? I think it was 24. I might be misremembering that. But anyways, we're going to play that clip. It's very important. I haven't seen anything recent from Sheila. I actually haven't subscribed to her channel, so I should probably see if she's got anything new going on with the coils. Because she has a really nice vortex coil. I don't know if she made it herself or somebody made it for her, but it was really nice. And it's basically the same method that we use here with our coils. I'm not exactly sure which frame. I'm using the Dragon 7 frame from the free coil frame archives that are in the public domain. We are not using any kind of proprietary frame or anything like that from One Stop Energies or anything like that. We're using our own free open source frame. And I think the point is that even an approximation, as Randy Powell would say, of the vortex-based math coil, even an approximation of that work can yield phenomenal results. So I think as you get closer to that perfect coil design, you get more and more interesting effects. But even the weakest approximation of that work should yield good effects. And I think we've kind of proved that with the Mark I coil that I've made, because it is not a perfect coil. It is far from a perfect coil. It's the first coil I made, so obviously it's going to be kind of jacked up, but it works. So I think the point is, it is really easy to achieve this kind of effect with the geometry, because the geometry does the heavy lifting. At the end of the day, it's the geometry that produces, in my opinion, the field cavitation effect. You know, all you're doing is creating two counter-rotating electromagnetic fields that are occupying the same space, and then you're timing them correctly with the proper circuits. Now, you can do this in different ways. You know, you don't have to use a modified joule thief to do this. You can use a capacitor to dump that energy into a battery, which Mike is utilizing with his double pole method, which we'll go into in a little bit. But there are different methods that hopefully can achieve the same effect, and we're going to be analyzing the reproducibility of the resonant pulse waveform to see if it actually appears in this circuit. I'm really curious to see what's going to show up on the oscilloscope, because it might be something completely different. You know, we might not actually find a frequency where it actually shows those characteristics. So I'm really interested, and I'm really excited to get into the mini lab, but we have a few more things to go into before we go into the mini lab tonight. So let's transition into a short break, a short intermission, and while the intermission is going on, we're gonna load up the Cosmic Summit clip of the highlights from Sheila's presentation with those coherent waveforms, and hopefully we can get some kind of similar effect tonight as well with that.
Well, so cymatics would be the closest in a physical medium that we could use in order to visualize the material shifting and creating more coherent geometries. Some people work with salt, some people work with Sedona red rock, some people work with shungite powder. Each one of these types of powdered minerals will potentially have a different impact when different frequencies are applied to them. So this geometry is from the plasmoid unification model is now getting imprinted into the electromagnetic field, and the EMF mic is proving it. So can I see someone's cell phone again? Can I see your cell phone? And then we'll just put the phone into the field. Look at that. So this is your brain. This is your brain on EMF. Don't do EMF. Just kidding. You can do it. Just, create some boundaries.
Right. Yeah. Yeah, nothing new under the sun. Sorry? With permission of the owner. Can we pass this around? Okay, yeah, so you're the one who came up with the idea. It's your responsibility if it goes missing.
It's such a special thing, and I have to thank the Matsumoto family for entrusting me with the project. Far in the universe, nuclear collapses very often take place by the gravitational force after stars consume their fuel. Since the electromagnetic force is about 40 orders stronger than the gravitational force, it should be easy to induce similar nuclear collapses by the electromagnetic force in laboratory. But we never knew until now how to do that. Recently, the author, Dr. Takaaki Matsumoto, discovered a nuclear collapse which was induced by the electromagnetic force in laboratory during studying the mechanisms of so-called cold fusion phenomena. Several kinds of nuclear reaction which were directly induced by the electromagnetic force, called electronuclear reactions, ENRs, were found so far to occur in a special state of hydrogen clusters called itonic clusters, or micro-ball lightning. The nuclear collapse was one of the most remarkable reactions among ENRs, called the electronuclear collapse. Furthermore, very amazingly, completely broken materials by ENC were found to be regenerated to thin tubes and films of conventional elements such as carbon, oxygen, and iron. The latter process is called electronuclear regeneration.
So those are your crenellated spheres?
Okay, on the subject of the crenellated spheres. In several systems, if you have, at the bottom of a yin vortex, you are, in my view, at that point, you're twisting the ether in such a way that at that point, it starts to unravel matter. So in my presentation, I showed you this structure where I placed a Marsa gas, which has a special component in there, which is released when you burn the gas, and that produces this magnetohydrodynamic structure, and it has a vector down to a point where there's like, it's a torsion field, and it has a focus where in the structure of the physical vacuum at a quanta scale on a toroidal level above, there's the interaction between that vector and the toroidal vector of the structure of the physical vacuum above.
I don't understand why he can't just simplify this stuff so everybody can understand it. He's got to sound so complicated when he's talking about this shit.
Okay, so
like just explain it to me like I'm in high school, bro.
Now, any matter in that position will have the hidden matter within the energy ripped from it. And this is what Nina Kalagina was doing when she was using Psi-Force, which we have the capability to use. She was able to move material around, but she was also able to stop the heart of a frog and restart the heart of a frog with her intention through her hands. And then when one of her colleagues said, well, I'm not really believing this, try and do it to me, she did it and sent him into cardiac arrest. And they had to do CPR. So that's extracting chi. And it's just sad because there's two horrendous weapons that are possible with this technology that almost certainly have been developed, and you don't.
In a world where innovation is stifled by greed and corruption, there lies a hidden truth that could revolutionize our way of life.
Lenny, what are you doing? Are you seriously pitching a new show right now? I didn't authorize this. My God, only 5 minutes into your new position as co-host, and you're already adding to my tight schedule.
Yes, sir. I manage that schedule. But I did notice you have an entire 2 days available during your week.
Wait, you're not talking about Saturday and Sunday, are you?
Of course, sir. You have 2 whole days where you're free to work on new content.
Lenny, those are my days off.
It's okay, sir. I know you'll manage just fine. I have faith in you.
Do robots have faith?
I do. I have faith that you won't screw it up again.
You know what? It's fine. Go ahead. I'll just build my cold fusion Lego set some other time.
It's PON certified.
But I'm not telling them about my idea for a thunderstorm toilet. I'm gonna keep that baby close to my chest.
You know, that just sounds wrong.
It's a good idea. A toilet capable of turning any toxic human waste into, well, it turns into petroleum jelly.
Why petroleum jelly, sir?
You know what? I'm not sure. I don't think it's calibrated correctly.
Enough is enough. The world is at a breaking point. Catastrophic climate change, biosphere collapse, and a global energy crisis have been met with apathy, denial, and despair. The phrase unidentified flying object is a deliberately obfuscating term. What it really is an alternative energy and propulsion device. This is the real reason for the secrecy. These technologies, if they were disclosed, would end fossil fuels, pollution, and poverty overnight, and usher in a new era of abundance, freedom, and peace. Instead, they have been kept secret for over 100 years.
The more powerful the agency, the more powerful the group, the more powerful the cartel, the more they will resort not only to legal means, but to extra legal means to suppress their competition.
I said pretty early on, the problem is suppression. It wasn't really how do I make a free energy machine? It's how do I not get suppressed? Because what's the point?
Microscopic ball lightnings that when they discharge are tapping into that 0-point energy field and creating the motive force.
Boom! That's why the concussion from the thunderclap is so huge. There's this huge amount of energy that's actually sourced from the vacuum energy. All the dots connected. This is what's happening, right? So we need to make the thunderclap engine.
Imagine a future where clean, sustainable energy is not just a dream, but a reality. Discover the countless untold stories of free energy devices and the relentless battle against those who seek to suppress them for their own gain.
Black shelving. So someone comes along, they offer you $20 million for your device, it's a corporation, they put it on a shelf. Boom.
This power is something I have given my life for you the people.
Uncover the shocking tactics used by energy industries to control the narrative and maintain their grip on power.
You don't interfere with the big, powerful people. You don't put them out of business. They still have those 50-year leases on the lines and all the power transformers.
Environmental Protection Agency is a bit of a dictatorial police agency.
A shadowy government with its own Air Force, its own Navy, its own fundraising mechanism, and the ability to pursue his own ideas of the national interest, free from all checks and balances, and free from the law itself.
This is real, usable power. It's stable. It is not transient. It is not noise. Behind the lamps, that little box is putting out all of that power, well over 500 watts, and yet it is receiving less than 1/3 of a milliwatt of input power. The rest of that power is coming out of the surging energy of the vacuum, and this little box that you see right here, solid state, no moving parts, is the vacuum triode that's doing this very practical and historical work.
But indeed, it put out more energy than it took in. He was shot at once with a silenced rifle from about 300 yards. reads like a James Bond movie, but it's real.
There are men here that said they're FBI, and they got black vans, and they're taking all this equipment. What should I do?
It's called capture, where they try to rationalize away this problem and everything's fine.
From manipulation of patent authorities to infiltration of government agencies, the truth is stranger than fiction. But amidst the darkness, a glimmer of hope emerges in the form of renegade scientists and inventors who refuse to be silenced.
There is absolutely no question that T. Henry Morey had a system that produced about 50 kilowatts out of a 55-pound box.
In the shadows of capitalism's dark secrets, join us on a thrilling new show. Get ready to be inspired, enraged, and empowered as we delve into the Benefactor's Guide to Free Energy Devices.
Only on Beneficence TV.
They came to claim our world. What they didn't count on was him.
Showtime! Hail to the king, baby!
You might have heard a Joule Thief circuit hum to you before, but have you ever heard a Joule Thief circuit actually sing to you? This is energy recycling. 15.5 hours of continuous power compared to just 2.5 hours off of a standard inverter. While this traditional inverter already maxes out at 88.5% efficiency, we're breaking every limit with my Vortex coil system. This standard DC to AC inverter will only run for 2.5 hours on 12.2 watt hours of energy. But my system provides energy for a whopping 15.5 hours off of the same 12.2 watt hours. That's over 6 times more efficient. Not only that, the system will keep powering my lights well past 12 volts on the battery. This isn't just an upgrade, it's a new industrial revolution. This is the energy of the future, and you are powering it. Imagine a world where energy is infinite, where the power to fuel our lives doesn't come from burning the past, but from harnessing the future. This is the breakthrough that changes everything. 0-point energy, the power of the universe itself, unlocked, and you are the reason it is possible. While the world sleeps, you're awake. While others talk, we are building. This isn't just technology, it's a revolution. And it's happening right now, powered by you. So thank you so much for joining me here on Beneficence TV and supporting our goals in open sourcing 0-point energy technology and disseminating all forms of forbidden knowledge.
Changing the system, treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice?
There's a man named Michael with a vision to show. Building towards the goal, he's got the spark, dreaming of a future that'll light up the dark. But on the other side, Bill Nye's on the rise because that gold charts, he's cut down all the lines. And it just fits, it's all in the map. You can't
stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. In the heart of a lab, the tension was thick. Skeptics gathered round the table ready to pick. Show proof, but let the case clear. And I find the stream, nor just chasing a spin. But Michael smiled live with blindness eyes. Watch as I spin, let the naysayers cry. Go spin fast, and a heart full of fight. I'll show you the power that's hidden inside. Oh, Michael's rising like the morning sun. With the power of either, he will be outdone. Well, stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. I'm the best there's ever been. In base lab alone with my mind. Trivial theories, they all refuse to find. I've been working on energy for a brand new day. But even in the crowd, I'm still a castaway. Alienated from the aids of that adventure in disguise. Ideas ahead of time, dismissed with narrow eyes. Benefactor boy, dreaming about the world you can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy.
Alright, welcome, and welcome back to Beneficence TV Live in our interactive mini-lab. So this part I'm particularly excited about. We're going to connect the oscilloscope and hook it up to the impulse driver for the very first time right here on live stream. And I want to emphasize that I haven't actually reviewed this waveform yet. This is the first time I'll be seeing it as well. So you're seeing this with me for the first time, and we're going to start by establishing the operating conditions. And we'll probe different areas. We'll look at the drive signal. We'll look at the coil response. We'll examine the returning transient event. We're going to examine everything with a floating probe, because what fun is grounding out all the back EMF? But what the hell? We might as well use the standard method just to compare it, but all we're gonna see is a pulse. Maybe we'll see an H wave at certain frequencies though. That will be interesting. Anyway, so we'll start changing the operating conditions to see what happens, specifically the frequency with the PMW, or PWM. If the waveform changes dramatically when we change the load or change the frequency, that's an important thing to note. If the waveform remains coherent, that is also important to note. If we're seeing any kind of ringing or nested harmonics, we're going to be looking for characteristics that carry throughout probe locations, identifying a singularity in the system. So if we see any unexpected waveforms, we're going to investigate them tonight, live on our interactive mini lab. And if we don't see the waveform that I'm predicting we'll see, that's also important too. That really does tell us a lot. It'll be a little bit disappointing, I'll be honest, but a prediction that fails is still useful information. And we're still going to have a lot of fun doing this. Because the entire point of doing this experimentally and live on camera is to distinguish between what we think should happen and what actually happens. We're doing real science here tonight, ladies and gentlemen. And we're going into it with a few predictions, but trying not to have any assumptions. So that's a hard line to toe. So the idea is to take the waveform information and represent the relationship between the signal in a way that makes the geometry of the oscilloscope easier to see with the Sheila-Raman method. When coherent signals are represented in this way, you can get these circular looping trajectories, as you've seen in the Cosmic Summit video on the intermission. And these appear to be waveforms that continuously return into themselves in very intricate ways. If we are able to reproduce this, that would be visually useful information. Now, she uses a microphone receiver, microphone antenna, I think she called it. And what we're going to be doing is, I don't know what kind of, she probably has a fancy one, but we're just going to take a wire and loop it and then clip it to the probe on the oscilloscope. And hopefully that's enough to pick up this unique waveform. So tonight we're going to be using that method, if we can get it to work, as a way to visualize what's actually going on in the system. I think that'd be interesting to see at different frequencies if we're able to get that method to work. Again, I haven't tried that, but apparently all we need is a looping wire. I have to read my notes from Google. But that's going to be secondary to what we're doing here tonight. All right, so and after that, we're going to be talking about something a little bit more tangible. And after we do the interactive mini lab, I just want to briefly, because I am using the sulfated battery, it's going to be exhausted a little bit and ready for recovery. I want to show you the difference between the thermal runaway, the wasted heat that happens in a traditional pulse recovery system compared to the Bedini system. So that's very important. I think we need to document that because I don't think it has been well documented at this point. There might be a couple of like random short clips of John Bedini talking about it. I don't think he actually has any direct footage of him showing it. So that's very important because, you know, we have to document these things if they're going to be taken seriously by anybody. You know, like I'm not just trying to develop these systems for the hell of it. I want people to be able to use them if the fucking shit hits the fan. If the grid goes down, what are you going to use to power your house's lighting? You know, what are you going to use to charge your devices? That's what we're working on here. Real, tangible solutions to an ever-looming energy crisis, really. Just look at what's going on in Indiana. So one of the things, though, that we keep coming back to in my investigations is battery recovery systems and the relationship between electrical activity and thermal behavior in these recovery systems. So if you're putting energy into a battery or recovery circuit and a significant portion of that energy is just being dissipated as heat, that's something we should be able to measure, and we can. So we're going to compare the two approaches to recovering this sulfated battery with using a traditional standard recovery system and a Bedini SSG, which uses the negative energy. Is really a cold forge method. So I think that's really important because although it's a lot slower at recovering the battery, it's going to recover it without any damage to the plates. It's not like brute forcing it. And at the same time, it has the potential to recover it above the efficiency that it was delivered to you upon before even using its first cycle. So, you know, we're starting to see one of my batteries undergo the conditioning process more and more. It's about halfway through, and it's already starting to behave differently. You know, it's already able to hold at a higher voltage and stay there at kind of like a shelf, whereas a traditional battery would just kind of like slowly dissipate. This is interesting, but you know, it's telling us that we're conditioning this battery with negative electricity, and it's undergoing a chemical change where it's able to effectively hold that higher voltage shelf for almost any system that we put it on so far. So that's going to be very important, because if we want to maximize the efficiency of our system, we also have to think about the efficiency of the battery, right? The source, where your input is coming from. And I don't think that a lot of people consider that. Even in free energy devices, such as utilizing the vortex coil specifically, I don't think I've seen anybody, like I've seen Daniel Nunez, and he used a custom Bedini circuit, but I don't recall anybody talking about actually conditioning the battery with negative electricity first. Because what you're doing in these systems is you're returning that negative electricity, that recovery energy. Instead of grounding it out, you're returning it to the source battery. You want that source battery to be able to absorb and accept it properly. You know, most batteries, according to John Bedini, just aren't able to accept that unless they've undergone a slow and rigorous conditioning process. So that is very important, because going forward, if we have a really, really efficient system, we can theoretically squeeze even more efficiency out of that system by fine-tuning the battery this way, putting it through that cold forge. So I think that's something that has been often overlooked in developing the Rodin coil and these types of pulse systems, but I think it's going to yield phenomenal results. You know, we've already seen some interesting things that indicate that it could expand the system even further. So tonight we're going to take some temperature measurements, though, of these pulse recovery systems. I'm going to show you how hot it gets compared to the cold forge method, which, you know, improves the battery, doesn't damage it while it's recovering it, and it does so at room temperature. So that is very important. I think that's important to document, because one of the key things that we observe with the Bedini motor is that it can operate with very little temperature increase above the ambient. Like maybe if it increases, it's maybe 1 or 2 degrees above ambient. But it's, you know, still able to produce a phenomenal battery recovery effect and charge effect. So the caveat here is there is a trade-off. You know, the Bedini system is specifically, you want to condition your batteries beforehand, and they're going to take a while. It's a slower method, but it's worth it in the long run. I think it really is. But if you're interested in fast recovery, you know, it is faster once the battery is conditioned. But if you're looking for like something real fast, you would probably grab a traditional system. But just be warned that, you know, you're putting a lot of amperage through those plates. It has the potential to warp those plates, and you could be damaging the battery as you're desulfating it. And it's not. So with the Bedini SSG, you're vibrating the plates where the sulfation, the buildup on the plates, is literally disintegrating at a molecular level. With the other method, the traditional method, the hot method, they're just kind of slumping off in chunks and going back as sludge into the acid pool at the bottom. So it's not actually an efficient way of recovering your battery. It really has the potential to do a lot of damage. That's why I don't really like to, I don't even like to hook my battery up to this method, this pulse recovery method, knowing what I know now about how damaging it can be. But I am willing to sacrifice it if it is going to be damaging at all. I'm willing to sacrifice it in the name of science and documenting it, because this evidence needs to be documented. You know, like people like the Mythbusters put out a bad name for Bedini motors, right? They did a great disservice. By all means, they should be discredited and blackballed from, you know, ever talking about science ever again after the hack job that they did on the system, convincing a whole generation of people, of scientists and engineers, that the system was simply a joke. And, you know, as we've demonstrated time and time again on this channel, you know, that's simply not true. They built it completely wrong, and they convinced a lot of people that this system doesn't work. And it really does work, and it needs to be documented. So if you're interested in actually using a cold forge method and replicating these kinds of experiments with the battery, like we're doing with the Bedini SSG, go to kenergy.store, and Kevin will hook you up. You can get your own kit. He'll even give you custom options for your kit and a plethora of modifications and add-ons that you can buy, like a cat bank and all that stuff. So, and if you have any questions on how to set it up, Kevin is very friendly. He's very professional, and he knows his shit. He builds these systems very well. I've run this system that I bought from him for over 2 years now. Some of it for like long periods. I've run it for long stretch, like 2 weeks, 3 weeks at a time without interruption, just running smooth. You know, I do maintenance on it every now and then. I do grease it up a little bit, but it's very, very well made. Very well made system. kenergy.store. So the Bedini SSG has been particularly interesting to me because of its approach to battery recovery and charging. It's simply doing things a very different way than what we're taught in standard electrical engineering. Instead of simply trying to force energy into the battery as quickly as possible, we're looking at a pulse charge process that appears to behave differently than conventional charging. And that's just an objective fact from simple observations of the system, without making any assumptions. But the thermal behavior can also be dramatically different between standard recovery systems and charging systems. And that's exactly the kind of thing that deserves controlled comparison, right? That's the kind of thing that needs to be documented. Because when we're talking about the efficiency, we shouldn't only be looking at the voltage on the battery. I think it's something that's often been overlooked. As I said earlier, the battery needs to be looked at in terms of how efficient it is at absorbing energy and releasing energy. You know, we need to consider things like how much energy went in, how much useful energy was recovered, how much was dissipated as heat. That's a very useful one. How did the battery condition change? And are these repeatable results? Now, those are measurements that eventually matter to the larger picture that we're building. And then there's the double pole circuit. I think if we have time, we'll briefly discuss that, but that's Mike Duzz's newest development. He has been working on a new circuit. It's a modified Joule thief using what he calls a double pole method. The idea is that instead of simply allowing the battery to continuously feed the circuit in a conventional way, the switching arrangement creates another path for the energy and the returning pulse separately. So the transistors or the switches are handling different parts of the energy. Now, this yielded very promising results as he, connected the feedback. He connected basically the output back to the input, and the battery actually increased voltage slightly during the tests. So that's very, very important for our development, because that's something that we want to see the system doing well, is recycling that energy back to the battery, and then we condition the battery for the specific coil arrangement that we have in circuit. But seeing that is exactly what we want to see for, a modification to take our system, our lightning thief system, one step further. I think he, found the next best introduction to, the Joule Thief. I think it's literally like the Joule Thief 2.0. So, but to be very clear, the voltage didn't rise indefinitely, right? We're not claiming a perpetual motion or anything like that. But if the voltage can increase under a particular operating condition, while the circuit is simultaneously delivering useful output, that's interesting enough for our system, and I think it's exactly what we're looking for in terms of the features that we need to maximize the efficiency of the Joule Thief design. So that's something that we're going to be developing in the future. And Mike did this with just a standard solenoid. He didn't use a vortex coil. So, that's very important, because we're going to have to adapt the system to work with our coil, but it might yield different results. So that could be good. It could be bad. We'll see. Hopefully good. All right, I think we're getting ready to set up the oscilloscope. I think that's everything I wanted to discuss. Just checking my notes. All right, yeah, I think we can get into the interactive mini lab. So what I'm going to do is I'm going to hook up my phone and see if I can get that camera to work for you guys, so you can get a nice close-up of the oscilloscope and everything that's going on. I'm not actually going to show you the circuit just yet, because I want to keep that for our Patreon paid members. Remember, if you want to get the schematics for the impulse driver circuit, they will be open source to everybody eventually, but for now I want to keep them for our Patreon subscribers, just to say thank you. And anybody who is interested in joining Patreon to help fund this research, it's a big thank you. So I'm going to put those schematics up there hopefully by the end of the weekend. But if you go over to Patreon/Beneficence TV, you'll find my page there, and you can, I'll put it on the basic. I'll probably put it on the basic, but you'll see it on the front page hopefully by Sunday. I think I have, if I'm not mistaken, I think I have 3 different tiers for the Patreon. I can't remember. It's been a while since I've checked it.
Oh, that's exactly what we want to see, baby. Oh my God. Look at that. That's it. That is it. Let's look at the convergence point. Oh, wow. That is wild. That's it. Those are the three characteristics. Let's see if the fourth. Put on the battery. Yep, yes, sir. That's it. Convergence point is slightly different on the source, though. We're going to try changing the frequency. So I switched the probe location to the actual output, positive rail. And we're at an extremely high frequency, 63,000 or 63 kilohertz. So 63,000 hertz. Never actually ran the system this high before. And we're at 80% duty cycle. And that is very interesting how the waveform changes. It's like dead for a huge portion of it, like from like 9 kilohertz up to 40 or so kilohertz. It's dead. And then it comes back in this very weird way. But look at all those nested harmonics. Pause it. It's just one line. Wow, and that's on the negative. Okay, so let's ground this out and see what the actual output is. Damn, that's a lot of nested harmonics. Oh, wow. So this is what it looks like when it's grounded properly, the probe, not just floating. It looks like we're reading 500 millivolts and negative 6.38 volts. If I'm not mistaken. Yeah. Let's see if the camera can do that. So if that's the true reading, that's a huge difference in negative and positive potential in the output, which is, again, something we see as evidence of energy partitioning happening. Interesting. Very cool. Let's decrease the frequency a little bit. Right now we have it set to 63 kilohertz. Let's bring it down. Wow, 7 kilohertz. Large spike on the positive. Doesn't look like those readings are changing at all. 7 kilohertz is still at 500. Huh. We see that massive spike right as we hit 7 kilohertz. Let's try to hone it a little bit. Oh, wow. 7.2 kilohertz, 80% duty. Look at that. That is interesting. Wow. Oh. Mm. They look like H waves on both axes. What? Let me pause it. Oh shit. I hit the wrong button. Yeah, look at that. Appears to be symmetrical. With a little bump in the middle. Okay. Okay. Oh shit. There we go. See, I'm looking for a smooth up and down. These seem to have little bumps in them. Might not be at the right frequency we want. So it looks like maybe nested harmonics on the edges of the waveform kind of smoothed it out a little bit. At least visually. Wow, look at all that. We're at 8.6 kilohertz. Okay, so I increased it to 90 on the duty. Currently 7.8 kilohertz. And this is a floating probe. Nine kilohertz, 90% duty. All right, so we're all the way at 60 kilohertz right now. You see how the waveform changes as it gets really, really high. Gets thick. Damn, boy, she thick! All right, I'm gonna try to put this thing in XY mode and see if we can make that mic antenna real quick.
That's interesting. Why'd the camera shut off? Damn, I hope that wasn't off the whole time. If so, we'll have to do that experiment again so you can see it on camera. But right now, I want to make that mic antenna. See if we can pick up that other waveform. Gonna burn the enamel off so we can make the connection. Alright. We have our secondary probe. Put a little tape on it. Should be good to insert into the coil. Now I just need to look up how to put it into XY mode. 110.4xe. Press acquire button, navigate to the soft menu option on the screen and toggle XY mode. Okay. So it basically pulls it off of the time measurement and puts it on a physical graph, XY axis. So push the acquire button. Okay, just to go over real quick, because I wasn't sure if the camera's off or not. We do find the 3 and 4th defining characteristics of the resonant pulsed waveform in this system. So this is synthetic AC, and it fits into the model. So this is very important. In case the camera didn't capture it, I wanted to go over it again. All right. I think it's okay. Let's do this. Let's try it. Well, that is interesting.
This is at 1 kilohertz. We have it set to 432 hertz.
Interesting. We're going to have to mess around with this a little bit in order to get the effects that SNA Organite got with the coherent structures. You got a couple of circles and figure eights. But we got the method to work. And we're seeing some interesting stuff. Looks like more complex loop patterns, though. Either way, we kind of proved what we needed to tonight. That's pretty cool. Time to shut down the mini lab. All right, so we saw exactly what we wanted to see and what we predicted we would see. Those three characteristics. We saw a 0-point convergence with huge sideband activity at certain frequencies. We also saw many, many more nested harmonics and more organized than in the Lightning Thief system, which I think is important to note. And then we also saw the macro scale sine wave. Now, I couldn't get it exactly smooth, but I suspect that the thickening of the edges, the harmonics that add on top of the main signal, that's what gives the Lightning Thief RPW characteristic smooth visual or smooth effect. We just can't really see the dense middle because it's so dense, but it is a little crooked. So I'm not really sure how that plays into the efficiency, if at all, but we're going to try to continue to probe these systems until we figure out how to determine the most efficient frequency for them based on actual oscilloscope readings and, not just like hunches. So we want to go off of actual observable data here, because simply we really can't measure this energy, and we have a theoretical framework for measuring it, but I need to get a high-speed current probe for the oscilloscope in order to do that. So yeah, so we something just chimed in my ear. Anyways, yeah, so we saw what we needed to see. My predictions were accurate, and it fits the synthetic AC model to a T. Now, we did see some additional effects, as I was mentioning. The nested harmonics at certain frequencies appear to be more organized and stacked. If you saw it on the oscilloscope, it makes you would understand. If you've seen it, it just it looks more even. And when we ground the probe out, this specific frequency looks like, I think it was like 7.2 or 7.8 kilohertz. It at 70% duty cycle, it was like the wave, it looked like a tunnel. So it was bouncing off of itself in an even way, so it was perfectly on top of itself, making kind of like a horizontal tunnel across the oscilloscope. So that was really interesting. When you ground the probe out, we've seen that. I think that might be an interesting frequency to pay attention to. Again, we really don't know. We're kind of just theorizing what's efficient and what's not, but I'm definitely going to be paying attention to that. Now we have one more test to do. We're going to do the thermal test because I want to get this battery desulfated this weekend so I can start conditioning the other battery again with it on the Bedini motor. We're going to do a thermal test real quick, and then we're going to end the podcast. So I really want to thank everybody for tuning in this evening for our interactive mini lab. It is really cool to do these experiments and do them live and have feedback and have you guys, give me suggestions. But I'm going to end it pretty soon because I'm getting a little tired. So we have a traditional pulse recovery system. Here, let me pull it out for you. So this is just your standard inverter. It converts DC to... I'm sorry, it converts AC to DC. Get a little tired. So we're going to demonstrate that this standard pulse recovery system is wasting a lot more energy in the form of heat. And it is brute forcing its way into its objective. Compared to the Bedini motor, we're going to compare that thermally and show you that it doesn't really go above ambient. So that's pretty cool. And I think it's important to document that because these effects for the Bedini motor, outside of Bedini's, very obscure and hard to get a hold of energy from the vacuum, that series, that there's really no source documenting these effects. Not that I've seen. So we're going to document the thermal comparison of a standard pulse recovery system to a Bedini and, objectively show that, the system runs cold. Okay, I put it on repair mode. I'm going to bring up the camera now. I'm going to take some thermals. Give it a minute or two to warm up, though. There we go. You can hear it, it's loud too, because of the fans, because it gets hot.
So it's in recovery mode. Let's see if I can zoom in. Yeah, so that end there, the little plus and heart symbol, repair mode. It's flashing recovery. Get it right on the terminal. So it's going to take a minute for it to heat up, though. We're going to monitor it. So already we're at 78. Remember, our ambient's around 77, 76. Yep, we're already at 78. Okay, so we're going to let it heat up for a minute and see how hot it gets. Again, it's going to take a few minutes for it to heat up, but it will heat up. And we're going to take another thermal reading in about 5 minutes. We'll watch a video or something, and then we're going to compare it to the Bedini, and we'll let that run for another 5 minutes or so, the same amount of time. Actually, I think it'd be a good idea to go to a quick intermission, and then when we come back, the temperature reading should be ready. Nice. So don't forget to hit that like button and subscribe for more revolutionary content right here on Beneficence TV. Woo!
In a town down south where the fireflies glow, there's a man named Michael with a vision to show. Billy told to go, he's got the spark, dreaming of a future that'll light up the dark. But on the other side, still lies on the rise, because that old chart he's cut down all the lines. And it just sticks, it's all in the map. You can't pull from the ether, you're just chasing a path. But oh, Michael's rising like the morning sun. With the power of ether, he will be outdone. Now stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. In the heart of the land, the tension was thick. Skeptics gathered round the table ready to pick. Show the truth, but let the case clear. We're not buying the stream, you're just chasing a spin. The Michael smiles by, the fire in his eyes. Watch as I spin, let the naysayers cry. Go spin fast, in a heart full of fight. I'll show you the power that's hidden inside. Oh, Michael's rising like the morning sun. With the power of ether, he will be outdone. Well, stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. I'm the best there's ever been.
So, quick update before we come back. The ambient temperature of the room was about 78 degrees, or is about 78 degrees, but the battery was still a little bit hot from coming off of the system being used by the circuit that I was using. So that's why it was 77. I did another check on a different battery that had been sitting there, and it is about 73 degrees is the temperature where it's not hooked up to anything. So 73 degrees is our baseline temperature that we're comparing it to, not hooked up to anything. Now that temperature is going to rise a little bit, maybe 1 or 2 degrees with the Bedini. With the pulse recovery system, I've seen it rise up to like 80, and even the system 90 plus degrees, like when you point the thermal at the actual inverter itself. It gets very, very hot. Whereas the coil, it doesn't get hot at all. So the coil and the system, both, the Bedini and our Vortex coil, they both run very, very cool compared to these other systems. So it's interesting because we have the same effect as an inverter with our system, and it doesn't have the thermal runaway or the heat associated with all these coils and transformers. So that's pretty cool.
My fellow Americans, I want to talk to you about something that has been a topic of much debate and unfortunately too much misinformation. For decades, we've been told that our future depends on scarcity, that our energy needs are limited and must come from a select few sources, many of which are polluting and inefficient. But I'm here to tell you, it's time for us to rethink the very foundation of how we view energy. The idea of free energy devices has long been dismissed as fringe or in some cases outright conspiratorial. But it's important to recognize that this is not a new idea, nor is it a pipe dream. It's a scientific possibility that many credible thinkers, including Lieutenant Colonel Tom Bearden, have been trying to bring to light for years. You might not have heard about it in mainstream circles, but those who have looked into it, real scientists, real engineers, are showing us that we can tap into an energy source we've barely scratched the surface of. The vacuum. Yes, the vacuum of space itself, a limitless field of energy that, like Nikola Tesla once envisioned, could power our world without the need for fossil fuels, without the need for waste, without the need to pay for energy at all. It sounds like science fiction, but it's grounded in real, proven science. And yet, for far too long, it has been suppressed. This isn't just about new technology or gadgets. It's about a revolution, a true industrial revolution that could lift us into a future of abundance, a future where energy is not controlled by a few, but accessible to all. That's why I'm asking you to start rethinking what we've been told. We're no longer calling it free energy. We're calling it energy recycling, because that's what it is. It's harnessing the natural forces that are all around us and making them work for us. I know it may sound radical, but it's time we ask ourselves why this hasn't been part of the conversation until now. Why have those with the power to make a real change in our energy systems continued to push for scarcity instead of abundance? Why has this potential been buried in favor of systems that benefit a few at the expense of many? I believe it's time we change the narrative. We have the knowledge, we have the tools. This is not just about science. This is about our future. The energy revolution is here. It's time we embrace it. Thank you. God bless you. God bless America.
Have you heard about this Benefactor guy? This dude is talking about free energy, but here's the twist. He says it's not free energy. He's calling it energy recycling, which first off is kind of genius, right? Because when you say free energy, people immediately throw you in the crazy bin. But energy recycling, that sounds like some next level Tesla shit.
Yeah, man, it's all about the branding. But what is it that he's actually doing?
All right, check this out. He posted this. Free energy isn't actually free. This is a misnomer. It's actually a mutual exchange from the vacuum, a field of energy from which everything arises, the same energy that powers an atom. Like, what? Bro, that's some deep shit. But then he breaks it down. He says, you can tap into this energy without breaking any known laws of physics by using something called back EMF capture.
Whoa, back EMF capture? Sounds like some serious sci-fi tech.
Dude, listen to this. He explains that when a coil collapses using a pulsed signal, the energy that would normally just get wasted, like just dissipate as heat, can actually be recycled. He says nature gives you back energy to stabilize the system, which makes sense if you think about how nature works. Like everything in nature is always trying to find balance, right?
So equilibrium, is that like how water always levels out or something? I'm trying to remember what Ms. Murphy said to me in 6th grade science all those years ago. What was that? Oh yeah, Elon, stop eating that glue and pay attention. Man, if only I had listened, I'd probably be the one inventing energy recycling instead of just talking about it.
Exactly. So he's saying that by intentionally destabilizing the system, collapsing the field, you actually get energy back as a kind of natural response.
All right, quick update, a little bit of a disappointment. It appears that my thermometer is malfunctioned or needs to be recalibrated. It is not picking up any kind of readings that would be normal. So what I mean by that is it's actually gone down in temperature. So either the system we had it hooked up to had some kind of effect, or my thermometer needs to be recalibrated. So we're going to revisit that test in the future. I need to make sure all of my equipment is on point before I run that test again. I need to recalibrate the thermometer and make sure it is not, giving us some weird readings. So I don't trust it. I'm going to recalibrate it, and hopefully I don't need to replace it. But yeah, that's unfortunate. I won't be able to run the thermal test tonight, but we will run it in the near future because I think that's important to document. It's something that I've wanted to document for quite a while now, and it figures the moment I'm ready to do it, something like this happens. So either way, we accomplished what we wanted to tonight, and I appreciate you for joining me on this journey, discovering new resonant pulsed waveforms that are emerging from the impulse driver system that will be available soon on my Patreon for paid subscribers. So I want to thank you all very much for tuning in, and for the subscribers, I appreciate all of the love and support, and it is you guys who keep this channel alive. We are literally on a shoestring budget, so appreciate everything, everybody, and have a good night.
Shattering the silence, feel the power. Revelations on the rise. From the shadows, light emerges, breaking through the veils of dark. 0 points in gravity converge, yeah, guiding voices. Revelation start. Ancient whispers call. They're begging us to open our eyes. We stand tall, defying all their lies. Living in now, we're shattering the silence. Feel the power. Revelations on the rise. Civilization's on the rise.